Okay, we are ready to begin. So as I said earlier, 6002X will represent a big jump from physics to EECS. And let's just dive right into it and take a look at an example of the kind of problems that we might want to solve. So suppose I have a battery here that supplies a voltage V, and I connect that to a light bulb. And let us say that I wish to find out the current I that will flow through the bulb as a result of connecting the light bulb to the battery. Now, I don't want to find out anything else. All I want to know is what is the current through the bulb. I want to remind you that as I go through various parts of the course, I will point to readings in the textbook, and for this material in this set of segments, you will skim chapter 1 of your textbook. The readings are also indicated in your course at a glance handout. So for the kind of problem we want to solve with a battery connected to a light bulb, I want to find out what is the current I to the bulb. Okay, so here's my problem. Now I could do it the hard way. As I've said before, we have captured the way nature is through sets of equations. In particular, those that relate to 6002 are Maxwell's equation. So I'll parade a bunch of equations in front of you, and don't get scared here. This is a hard way, and this is not how we're going to do it in 6002X. I just want to show you how exciting and fun 6002 is and how simple things are. But let me start by showing you how we could do it if we were crazy. Okay, so I show you Maxwell's equation in equations in differential form or in integral form. So for example, this is Faraday's equation. Del cross E is minus del B by del T. In integral form, it is integral E dot dl is minus del phi B by del T, and so on and so forth. Now I could take Maxwell's equations, and of course you can go and solve all of them somehow. It'd be horrendously hard, but really this is not what we do in 6002 and not what we do as EECS engineers. Instead, there is a much easier way. Okay, we are going to make our life extraordinarily simple. So before I show you what that method is, let me help us build some insight. So let's do it by analogy. Okay, so supposing I have an object, and suppose I apply some force F to the object, and my question to you is, what is the acceleration of the object? Okay, so if I ask you this simple question, I have an object, and I apply a force F to the object, and I ask you, what is the acceleration of the object? I don't tell you anything else. All right. So no more data. I want you to think about how you might solve this problem. What sort of questions will you ask me? How would you answer this problem? Let me pause here for a couple of seconds and give you some time to think about the answer before I proceed.